Hello there guys, welcome back to another epic inexorable maths video. In this video we've got yet another double integral problem for you. So now that we are equipped with Fubini's theorem, we can have a crack at this one too. So this is a bit similar, but we're also including the R business where they tell you about the region, they don't actually give you the limits and stuff. It's a combination of that and also Fubini's theorem, so it's extra crazy. Okay, let's dive straight into it. So we've been given the region R, we've been given this integrand y x cubed e to the xy squared. Now again, if you've seen the previous video, you might look at this and start suspecting, can we actually integrate that? Because remember, we have to integrate it with respect to x right now. Can we even do it? Well, I mean, you could, but it's a bit of a crazy one, as you can see. It's going to take a few integration by parts to do, but don't worry, we're not going to do that. It's going to be a bit nicer for us if we know Fubini's theorem, which we do. So let's draw the region first of all. It's the finite region bounded by the lines y equals x, y equals 0, and x equals 1. So let's dive straight in and draw this region. Okay, so there's our x-axis. Here's our y-axis. Okay, so the line y equals x looks like this. Y equals x. There we go. Y equals 0 is just the x-axis, and x equals 1, maybe x equals 1 can be about here. And the line x equals 1 is a vertical line just like that. So it's the finite region bounded between all of these lines. And again, this is the final line. It's just I haven't drawn it on, but it's the x-axis. Clearly, it's another triangle. So this is our region again. It's this triangular shape. Okay, lovely. Okay, so notice something as well, guys. If this was integrated with respect to y, it would be much, much easier because it's either a u substitution or a reverse chain rule, however you know how to do it. Hopefully you can see, if you imagine x is a constant, it's easier. So what we would really like to do is integrate this, have our double integral. The integrand never changes, so it's written an equal sign. Y times x cubed e to the xy squared. And really we'd like to integrate this first with respect to y, then with respect to x. That's really what we're aiming to do, because it's easier to integrate this function with respect to y first. Okay, cool. So yeah, what will our limits be? So first of all, because we're going dy, our limits will be low down and high up. So what function is, or what it doesn't have to be a function, or it could be a constant, what is stopping us from having this region go down to the ground? Well, it's the line y equals 0. So our bottom internal limit will be 0. Lovely, okay. What is stopping us from going up to the sky? Well, it's y equals x, right? X is what is stopping this graph from coming up. Y equals x. So x will be our upper limit. Lovely. Now guys, remember, the outside limit must always be a constant, or they must both be constants, because otherwise your final value won't be a constant, which is not good, because it should be. So these need to be constants. What is stopping us in the x direction from coming towards me? Again, you might be inclined to say, oh, y equals x. You're not wrong, but it has to be a constant because it's on the outside. So the function stopping us from coming this way is just the line x equals 0, right? It's this vertical line x equals 0. Nothing gets past me. If I say stop at x equals 0, nothing from the region can come towards me. So x equals 0 is the bottom one. And going to the right is clearly just x equals 1, isn't it? Because nothing, if I say stop at x equals 1, you can't go beyond that in that direction. You cannot go beyond it. So 1 must be the limit there. Okay, and then we do this, but this is brilliant. We've changed the limits around. We're integrating with respect to y this time. So there's no integration by parts needed. I'm not going to claim that it's an easy integral, but it's easier than when we were going with respect to x. It's still not a trivial one though. So here's our integral, 0 to 1. Let's work out what this is. So you may even not want to just do this in one go in your head, right? Let's just take a second to look at this integral integrating with respect to y. So we've got y times a constant, x cubed, times e to the constant times y squared. So we should suspect that what's happened is the original function that has been differentiated is of the form something times e to the xy squared. So this is my proposition to you. I think it's going to be something times e to the xy squared. And I'm going to just fill in everything else now. So we've got our integral going from 0 to 1. I don't know what will be here though. There will be something here. Let's figure out what needs to go in front of the e to the xy squared. Okay, well let's see. Well, if you differentiate with respect to y, e xy squared, you will get 2yx. Hopefully that makes sense. But what we want is 1yx cubed. So what needs to be here already, there needs to be a half here, because then the 2 can be killed. And there also needs to be an x squared here as well. And just to make sure it's really, really clear why, let's differentiate this, see what happens. So if we differentiate a half x squared e to the xy squared with respect to y, the derivative of xy squared is 2xy. So we've got 2xy timesing by the original function, which is a half x squared e to the xy squared. Okay. The 2's cancel out, the board rubber. The 2's cancel out because it's 2.5. There's an x here, there's an x squared here. So I can write this as x cubed. And you have a y x cubed e to the xy squared, which is what we had there. So hopefully that makes sense, guys. I'm not claiming that it's an easy integral to do. The difficulty is probably the fact that you have to kind of do it in one go, just like by looking at it, but that's what it will be. It will be a half x squared e to the xy squared. Just remember you're differentiating, integrating with respect to y in this situation. Okay, cool, hopefully that makes sense. So now, at least it saved us from doing all that integration by parts, right? So now, let's substitute our values in. So the limits, I've written 1 up here, guys, sorry, it needs to be an x. I've just figured that out. Okay, so, right. 0 to 1, let's substitute everything in. Remember, we're substituting the limits where the y's are here, not where the x's are. So we've got a 1/2 x squared e to the x, and then, well, we're just replacing the y with an x, so it would just be x times x squared, which is x cubed. Okay? And then we're going to subtract 1/2 x squared times e to the x times 0 squared. That's just e to the 0, which is the number 1, so there's nothing to be written. Okay, and then dx. Lovely. This is our integral. And once again, this is a normal single variable integral. So we can do this hopefully without crazy amounts of difficulty. Let me just make sure that you can still see it while I draw. Okay, let's move this down slightly. All right, so let's do this. We have got a half squared e to the x cubed. Again, this is the one that's a bit trippy to think about, but this is going to be a 6th times e to the x cubed. And again, if you differentiate this with respect to x now, 3x squared is going to come down, and the 3 and the 6 will become a 1/2, and the x squared is there, so it's this. Subtract, and then we've got a half x squared. This becomes a 6th x cubed. Okay, and this is from 0 to 1. Lovely. Okay, and then we just substitute 1 in, so we get a 6th e to the 1, so just e, minus a 6th times 1 cubed, so just a 6th. And then we're going to subtract this with zeros. So subtract a 6th e to the 0 is just a 6th. And then a 6th times 0 cubed is just nothing, it's just 0, so like minus 0. Okay. This then becomes a 6th e minus 1/6 minus another 6th, so 2/6, which is a 3rd, but I'm not going to write it like that because I can factor out a 6th from both of these if I want to, and I can write my answer as 1/6 e minus 2, like that. Hopefully that makes sense. So that's the answer. This is quite a nice one. It's a nice answer. 1/6 e minus 2. So this whole thing is equal to a sixth times e minus 2. Hopefully that makes sense. So, not an easy question by any means, quite a little bit of funky integration. Make sure you're really good with your normal single variable integration methods. There was a little bit there. You don't have to use that Fubini's theorem, changing the limits around for this question. You can, by the looks of it, you can do integration by parts on this, but it just looks absolutely not pleasant whatsoever. So I would definitely just swap the limits around like this. That's why it really helps to draw the picture in every single question. Thank you guys, as always, so much for watching. I highly appreciate it, and I'll see you in the next video.